Okay, the second set of questions then were a wee bit trickier because you had to rearrange the equations. So there's a little bit more work to do here. So first one, resultant force. So this time we're given the force, unlike in the previous set of questions. And a mass of 50,000 kilograms. And we're asked to find the acceleration. So I wouldn't rearrange the equation before I put my numbers in. So I would always write out the equation exactly the way we learnt it, and that's in your notes. I would then put in my values. So the resultant force was 200,000. The mass is 50,000 times the acceleration. But I don't want to know what 50,000 accelerations are. I want to know what one acceleration is. So I divide this side by 50,000. But if I do that, I have to divide the other side by 50,000. So we divide both sides by 50,000. That will give us the acceleration. Those all cancel out. That cancels out. So it gives us that the acceleration is 4 meters per second squared. Okay, remember that's the unit for your acceleration. Question 2 gives us a resultant force as being 4,000 newtons. The acceleration is 0.2 meters per second squared, and it's wondering what the mass of the bus is. We write out the equation as per normal. RF equals MA. 4,000 equals 0.2 times the mass. Divide both sides by 0.2, which will give us 4,000 divided by 0.2 equals the mass. 4,000 divided by 0.2 is just the same as multiplying by 5, and it gives us 20,000 kilograms. Question 3 says there's a resultant force of 20 newtons, causes a ball to accelerate at 40 meters per second squared. What I should say is the mass of the ball, but it wants it in grams. Now, our equation doesn't deal with grams, so we can't deal with that at this moment in time. We just write out our equation, we put the values in the units we usually use, divide both sides by 40, and it gives us that the mass of the ball is 0.5, and whatever comes out of that equation, it's always kilograms. However, we then need to convert that to grams at the end, which means we multiply by 1,000 to get from kilograms into grams, and it gives us that the mass of the ball is 500 grams. Question 4, but as tricky as it gets really, gives you a mass of 1,000 kilograms, and it says there's a resultant force of 2,000 newtons. If I get a question where I'm given the mass and a resultant force, I would always be thinking I'm going to need to work out the acceleration here, even though that's not really what the question asks for, but it's going to be our first step. So we do RF equals MA, 2,000 equals 1,000 A, divide both sides by the 1,000, and it gives us that the acceleration is 2 meters per second squared. Okay, now if you remember from one of the previous lessons, that means that the speed increases by 2 each second, and it tells us our car is initially at rest, okay, which means the speed here is 0 meters per second. After 1 second, the speed will increase by 2, so it will then be going at 2 meters per second. After another second after that, the speed will increase by 2, and it'll be up to 4 meters per second. Another second after that, its speed will increase by 2, and it'll be up to 6 meters per second. So after 1 second it's at 2, after 2 seconds it's 4, and you can see we just add on 2 to the speed each time. So after 3 seconds it's going to be at 6 meters per second, and that's your answer. Okay.